Thank you very much for waiting a bit. Thank you for being with me. Thank you, Jimmy, for the floor. So yeah, let's talk about scaling semantic segmentation with Blender. So first, let me introduce myself. So who am I? So my name is Vincent. So I come from France. Okay, I bet you can hear it from my accent. So I have a PhD in nuclear physics that I defended in 2014 now. So I did this kind of funny stuff here about Monte Carlo simulation. It was pretty cool. In case you don't know, so I graduated from Paris Saclay University. Maybe you don't know it, but it's one of the top universities, especially in mathematics and physics, where it's ranked usually in the top 10 and right now top 3. About my background a bit, so I deployed ML models for large companies. So it includes Renault, that you may know. It's a French car manufacturer. I also worked for a couple of years at Chanel, doing beauty stuff. General Electric about medical imaging, or L'Oreal, again about beauty. I also worked in a few startups and scale-ups that you may not know so much. It's a bit more confidential, but for example, I worked at EasyRecruit a couple of years ago now, even 5 years ago now, working on hireability score based on video interviews, which was pretty cool, using both video but also sound and text, which was fun. I also worked at JSmack, where I was doing some forecasting of the revenue of a video on YouTube, which was pretty fun too. Besides that, so I'm also an author on Medium, so I have a few articles that I post there. So I try to post, let's say, every couple of months, once when I get the time. So here are a few that work pretty well on data science. I'm also author of the regularization cookbook. So it's a book about regularization in machine learning, of course, about tabular data, but not only, also going to deep learning, NLP, and computer vision, and how to improve your models using regularization. Since it's a cookbook, you also have all the codes available on GitHub, which is pretty useful if you want to get into that topic, if you're a newcomer. And so finally, right now, I'm head of AI at Pros. So you may never have heard of Pros. So it's a company doing ultra custom hair care and skincare. So basically, the way it works is you are going to do what we call a consultation online on pros.com. So you're going to answer a lot of questions about what you do, about your habits, or your expectations for your skin or your hair, where you live also. And then based on that, we have millions of combinations of formulas for your products, and we are going to provide you with the best for what you need, actually. It's direct to consumer. We are making all of our orders based on the orders, basically. Yeah. So we are B Corp certified because we have no waste, and since it's a very unique company, we have very unique challenges in terms of AI. So it's pretty fun, and we are currently hiring. So in Paris only, sorry, but if there is someone from Paris here, feel free to reach out to me outside of that. So let's get back to our subject today. So let's talk about semantic segmentation of hands. So we're going to talk first about labeling data for computer vision, especially for segmentation, which can be quite painful. And then we're going to go through a use case about generating diverse data and realistic hands. With Blender, generating a full data set and training and improving a segmentation model. We'll go through that afterward. So first, so if you want to make a semantic segmentation model or instance segmentation model for hands, if you want to have labeled data, if you want to have data sets, you have mainly two options. So the first one is labeled data, so which usually lacks diversity. So for example, we have the Ego hands dataset, which is quite useful and quite famous. So basically, the way it works is you have a bunch of people who took videos who recorded videos on themselves, doing a few actions like playing chess, playing cards in a few places. So it's really lacking diversity because you only have a bunch, let's say half a dozen people. So hands of only a few people. You also have like half a dozen contexts, like a room or another room or outside, but it's not really diverse, but it's labeled. And then you have the other option, usually, which is having data from the wild on the internet. So, for example, on Unsplash, as we have here. So in this case, usually you can find pretty diverse data with a lot of hands, a lot of context, a lot of background and everything, but you have no labels. So what if you want to get both? Well, actually, there is one solution that you can explore, which is making synthetic data with Blender. So before we dig in, let me tell you that there are, of course, other alternatives. So for example, you can use generic segmentation models such as SAM for labeling. You can also use diffusion models such as Stable Diffusion or Flux to generate diverse data set. And so if you want to explore that way, this is something I did in another post on Medium. So this is, let's say, a bit outdated. It was 1 year ago. The models are not the same. It's going really fast. It was SAM. Now we have SAM 2. It was Stable Diffusion 2, I guess. Now we have 3. But still, you can have a look. You still have a good methodology about how to do that. So back to our initial problem. So what's the plan? Trying to improve that. So to make it work. So first, what we would like to do to see if we can improve with Blender dataset, we're going to have to train a semantic segmentation model on Ego hands dataset. And then we are going to compare that if we try to train the same model with Ego hands dataset plus our Blender generated dataset. And then we are going to check what are the improvements one to the other. So, of course, this is the plan, but this is what we're going to do at the end. First, we need to create the Blender dataset. All right, so let's get to that. So here is the overview. So first, we're going to generate our data with Blender. Then we're going to generate an actual dataset from that data. And then we're going to train and improve a segmentation model. All right, let's go. So first things first, why Blender? So it actually comes with a few advantages when it comes to generate realistic objects. So first of all, why it's free. You don't have any commercial license, so anyone can use it for free, which is quite convenient compared to other tools that may be quite expensive sometimes. Then you have a great community. So meaning not only you can have a lot of information on forums about how to use it, a lot of YouTube tutorials, everything. You also have many 3D models online. Some are free, some are not, some have licenses that allow to use it free, but not for AI training. So you have to check that carefully. But anyway, this is really something interesting. You don't have to be an expert in Blender to use Blender, which is pretty nice. And finally, one last great asset. So you have a powerful Python API. So we are going to use that extensively to leverage automation and generate a lot of data automatically with just a bunch of code, of lines of code, basically. All right. So how are we going from a model? When I say model, it's not a machine learning model, but a model of a hand to diverse data. So actually what we're going to do is 3 steps. So from a freehand model that I found online, I'm going to generate diverse images with first moving the fingers positions to have a lot of finger positions, quite realistic ones, hopefully. Modifying the skin tone so that we have diversity in the skin tones, and then changing the camera angle so that we don't have always front-facing hands from the same angle. All right, so we're going to do that. And of course, I did not mention it yet, but what is really interesting is that with Blender, we can actually have automatically the segmentation mask of that hand. So we basically have the labels as soon as we generate our data, which is quite convenient because we don't have to, well, label anything and it's costless. All right, so let me just give you a small introduction to Blender. So just to show you what it can do. So basically here is my picture of a model, of a hand that I found online. So I didn't do much on that. It already had what we call the rigging. So meaning basically the bones. All right. The only thing that I did is, thanks to a YouTube tutorial that I can find online, is that I added those controllers here. So, and I called them controller. I mean, nothing very fancy. And what it allows me to do is that with given some constraints here on the location it can take and a few other constraints, if I move those, I'm going to be able to move, you know, in a quite realistic way, the way my fingers are moving. So let's try to do that. This one here, see here, all right. And so you can do that with all of them. You can also move them in other directions to have a small lateral movement. And so you have constraint on them that I added, so it cannot go too far in one direction or the other, so that will remain realistic. I mean, you don't want to have your finger going inside the palm of your hand or anything, or to go back in an unrealistic way. So this is what I did. So it's not a lot of work usually, because all the model was already available. And then from that, we are going to automate and generate a lot of diverse data. All right, so the first thing was modifying the finger's position. So we need realistic, diverse finger position, and actually we can automate that quite easily with the Blender API. So I just added here a small snippet of code, but basically it's really easy. All you have to do is just change a few options, like saying, okay, here is my active object, this is my edition mode, so that's the one where you can actually move fingers around. All right, and then I'm gonna just loop into all my bones and just check the ones with the controller name. So which is why I told you it has name controller in it. And as soon as I have that, I'm gonna just randomly draw a value for the new location of that controller for X, Y, Z. All right, and based on that, it's going to move my finger around in a realistic way. And so here is the result. Oops, sorry. Here is the results on the right with a few generated images of fingers, so you can have quite realistic and diverse data. Of course, you can generate much more, which is what I did in practice, but here is just a subset, all right? So, of course, mention here it again, even if I already told you, but you have to really well define the constraint, otherwise you can have really unrealistic finger positions, well, which make it a bit less unrealistic, of course. So then you have to modify the skin tone. So this is the second thing that I did. So for that, actually, I didn't find a nice way to do it in Blender. I mean, an easy way to do it in Blender. I guess you have to be kind of a master in Blender, or at least in making mesh, because you have to play a lot with not only the colors, but also the reflection with the light and so on. So since I was not an expert and I didn't want to become one, I didn't have time. What I did is a bit of image processing, you know. So what I did is a workaround, and just based on a given image of a hand and a few hard-coded skin tones that I found online, here is just the X code of the color, I could just apply an image processing on that. So before showing you a bit of the code and how it works, it's not complicated. Just a few words here. So we need diverse skin tones to avoid any bias. So here I did it, let's say, quite easily, but if this is something you want to address in your use case, you have to be really careful here. You can have a lot of ethical bias here, so be really careful about that. Make a good evaluation and make sure you have the right skin tones that make sense for your use case. All right. So here's a bit of code and basically the results on the right. So the way it works, it's quite easy. So basically what I do is just having an input hand, image of a hand. I'm going to compute the average color of that hand. And then I'm going to have a target color. So based on my list of skin colors that I want to have. I'm going to compute, well, just the difference between this target color and the average color of my input hand. And then I'm going to apply, basically, this difference to all of the pixels. And I'm just going to add a clipping to make sure I'm not going outside of the 0 to 255 range, a bit of blur and everything, but basically all the job is in the first part, and then as a result, I'm going to have this kind of result. So here is a few hands that have, well, now diverse finger positions, but also diverse skin tones. So here we go. All right. Next step, so modifying the camera position. So of course, we don't want to have only front-facing hands. It won't be so much generic and diverse. So what I did is just having my camera moving around in many directions. So to do that, I just applied the spherical coordinates. So spherical coordinates here are calculated randomly. So basically, I just have a fixed radius, meaning I'm gonna keep the same distance from the center of my hand to my camera. This is fixed. And then I'm going to draw random values for theta and phi, which are the two other coordinates in the spherical space. And then based on that, I'm just going to make a conversion back to the Cartesian coordinates, x, y, z. And then this is going to be the new position of my camera. And so here are the results. So I have now images from various angles and perspectives, so that we have now hands with diverse finger position, skin tones, and angles, I would say. All right, so now that we have that, let's go to the next step, which is actually making the data set. Right now we have a lot of hands, quite diverse. Okay, that's cool, but we cannot use that directly. I mean, you could, but it's not so much realistic. Usually you want hands to be in a given background and various backgrounds too, all right? So to do that, well, we actually need two things, quite straightforward. So we need background images, of course, with no hands, because if we have hands in those, we're going to have hands in our data with no labels, which would make no sense. And then we're going to blend those images with generated hands that we made just before, all right? So what I did is quite easy. I just collected a few background images on Unsplash. So I just typed in a few keywords like, I don't know, room, some kind of objects, people, or places, whatever. So you have quite diverse data. You have to make sure it's quite diverse with different lightnings, different kind of objects, and so on, so that it's, well, diverse enough, you know. And then I blended my background with my hand. So it's the way it works, it's quite straightforward. So from my set of background images and my set of hands images that I generated with Blender, I'm going to pick a random one in both of those lists. Then I'm going to pick a random position in my background image, and I'm going to blend in, well, the image of the hand that I did. Since I have the mask and everything, it's quite easy, nothing complicated. And then I'm going to compute a new image and the new mask, and here is the kind of result that we get. So as you can see, it's not so much realistic in some cases, but at least we have quite some diversity here. All right. And so that brings us to the last part, so which is training and improving the actual segmentation model with this data. So what model did I use? So what I did is just using a UNet with a pre-trained MobileNet V3 backbone. So here is just a reminder of what is a MobileNet V3. I won't go into the details. You actually have quite a few, let's say, flavor of the MobileNet V3, large, small, and so on. I think I used a large 100, if it's interesting for anyone. Here is the UNet. So basically, we are going to use the backbone of that in the let's say down sampling, and then we are going to make up sampling again to have the same image resolution as an output of the neural networks. I did that with a segmentation model PyTorch, which is quite convenient and easy to use. Also, I did some typical image augmentation, so image flips, horizontal, some brightness, contrast, randomization about that. Also some rotation of the image, some random crops, so all the typical stuff that you can do with albumentations, you know. About the loss, so I used the binary cross-entropy because you basically have here two cases. So either it's a hand, either a pixel is a hand, either it's a background. So binary cross-entropy works well. About the evaluation metrics, so what I used is the IU, intersection over union, between, well, actually the hand pixel and the background pixel. All right. And so as a result, when I train this model on just the train set of the ego ends and evaluate it against the test set of the ego ends, so I have an average IOU of 0.72. And then when I do the same, meaning I have, but with my Blender dataset, meaning I have my ego hands dataset train set plus my Blender dataset, and I train on that my model, and then I evaluate it against the same ego hands test set, and I have an improvement on my average IOU. It goes up to 0.76, which is, let's say, a fair improvement considering what we did here. So before concluding, just if you want to go further about that, let's say here it was just a first test, so you can go much further. Let's say you can add more hand models. So actually, if it was diverse enough, I would say that, but not so much. I mean, it was always the same shape of hand. You could add a lot more reality and diversity with adding a few more models of hands. So here is just a few examples of hand models that I found online on Blender. So, you know, some ones are a bit, look a bit older, someone bigger, smaller, leaner, and so on. So it can be really useful, I guess, to use this kind of, let's say, wider diversity of input hands. Of course, something that was quite unrealistic was the skin tones that are not matching between the human when there is one, the person basically, and the hand. So here are a few examples that are not really matching. Also, the hand and face sizes are not always matching. So to do that, you could use, let's say, models like MediaPipe to compute easily the size of the hand and the size of the face to make sure it's matching somehow. You could also improve the Blender generation with adding more diversity, more lightning, more anything that you want. I guess I didn't explore all of the parameters. And that's it for me. Thank you, everyone. And I'm going to check if there are a few questions.
Yes, it does look like there are a few questions in the Q&A. If you'd like to go ahead and grab those.
Sure, let me check. So, sounds like you are a one-man band on the synthetic data generation. Mind sharing how long it took you to get a good data set? Well, actually, it didn't take so much. Actually, what was so much time. So what was complicated was really to get into the API of Blender, having a first working model. So basically, what was really complicated at first is what really doing that part. Once I had that with the Blender and something working realistic here, since it was really not in my skill set at first, I had quite a hard time. But then as soon as I had that working, it was quite straightforward because the Python API is really easy to use. And then, well, it wasn't my skill set to just train a model and so on. So it was quite easy for me. I'm going to take the other question by mentioning diverse set. Do you mean that set with different size of hand, set of hand? Well, that's a good question. That's a good question. What I mean by diversity is exactly what you mean. It's basically having something that covers all the possible hands that we can find in real life. So while what I'm presenting here is not so much diverse, you can add much more, as you said, like child hand, female hand, my hand, anything, hairy hand, whatever. I think it's a good. I think it's a good start. You know, if you are just taking a random dataset like ego dataset, you have like 6 different hands maximum. It's really nothing. So it's really not diverse. Here you can have at least a lot of skin tones, a lot of backgrounds, a lot of finger positions, which can be really helpful in some cases. So yeah, what I mean by that is hopefully something that covers all the possible types and kinds of hands that you can find in real life. All right, so another one. So I have not gotten around to this sort of thing in previous jobs, not just for AI, because the time it can take, it would be super useful to have tools to accelerate, bootstrap the modeling effort for a few images of the thing to be modeled any suit. I'm not sure I understand that question, Stuart. Let me read it again. Then you can take to build a model. Well, I don't know. From what I understand, you are mentioning that it takes quite a while to build a model. Actually, you have a lot of tools right now that can help you build a model from scratch in really couple of hours. So you can look at YOLO, for example, that is really good library. You have to be careful about the license too, because the license is not so permissive, but it's a good way to get into something working quite easily. Basically, all you have to do is create a data set with a given folder architecture, and then you just type in a command in your command line, and that's working. So I don't know, if you want to speak about that, feel free to reach out to me, because I'm not sure I understood well this question, but yeah. So next question. So to hand position expert, have you built a particular rake time typing detector to permit typing on the bar table or picture keyboard detecting fingertip? Well, trying to have something like Metados, basically, or all the VR tools. Well, it's a good question. So I didn't do anything like that. But it would be interesting. Actually, I think if you want to do that, or if you want to have a look at that, you can have a look at what Meta or other VR, AR providers are doing. You have a few models that are open source, but basically, I think it comes down to not only doing ML models about understanding the finger position. So it comes also to understanding the context, the scene. So with AR. And then you get, I guess, you would have to use the landmarks of the hand to make sure you have something that is working, not only the instance on semantic segmentation. It won't be enough. All right, and then last point, you can use ray tracing inside Blender to render more realistic images. Yeah, it is actually. All the images that I generated, right, as you have seen in this presentation, have been generated with ray tracing, actually. So yeah, indeed.